show this, how you would actually calculate. So d dx of y squared is then going to be the same as dy dx times d dy of that y squared. Okay, so what we're going to have is dy dx times, and the derivative of y squared with respect to y is going to be simply the 2y that we've learned from the power rule. Okay, so this is what we're left with that term. So now we're going to plug this back in for this spot, okay, that awkward term, and then we're going to solve. Okay, so I'll keep this as it is. All right, so this was our d dx of y squared. All right, so on the third step, I'm going to plug that back into our equation. Okay, so step 3, write entire equation. Okay, so that's the first part of step 3, and then I'll continue with another part. So what we're going to do is write the entire equation. So we have, for our first step here, we had a 2y, and then dy dx. I usually write the dy dx after. You can write it before if you'd like. I usually write it after. And then we have our plus 3x squared is equal to 0. Okay, and now what we're going to do after we do that is we're going to solve for dy dx. Okay? Alright, so this is basically our unknown at this point. So what we're going to do is just get that by itself, and then at that point we'll be done with the problem. So we're going to subtract this 3x squared over to the right side. Okay, so we get rid of that, and now we have a 2y times dy dx on the left, and a negative 3x squared on the right side. Okay, so now we're just going to divide by 2y, so we get finally that our dy dx, the relation between y and x, is going to be simply negative 3 over 2 x squared over y. Okay, so this is our dy dx, our first derivative of the given function. So as I mentioned previously, the problem that we just did it could have been done in a different way. It could have been in the beginning, because it was what was it, y squared and then plus an x to the third equals 7, right? So that could have been done in a way such that we could get y by itself, and then it would be defined explicitly, and we could just do our normal differentiation. But let's look at a problem where you can't get y by itself at all. So an example which would show that is an x squared plus xy plus y squared is equal to 4y. Okay, so this one is kind of a mishmash of a bunch of x's and y's. So let's do implicit differentiation with this, because we cannot possibly get y's by themselves, because we have this term especially. Okay, so let's go through the steps. So the first step is to d dx everything. Okay, so that's what we're going to do. So d dx everything. Exclamation point for emphasis. Okay, so if we d dx the left side, we get d dx of x squared plus xy plus y squared is equal to d dx of 4y. Okay, and then what else shall we do here? So then we get, we can break this up. So d dx of x squared first, plus d dx of xy plus a d dx of y squared is equal to d dx of 4y. Alright? So, what are we going to do with this? So this first term here, that's going to be an easy peasy one, right? We can just make that a 2x, alright? Because we're differentiating once with respect to x, and that's what we're dealing with. The variable there is an x squared, so that's good. But now we run into problems, right? Because now we have this y here, and we don't really know what to do with it. But what we can do is we see that there are two functions, an x and a y, being multiplied times each other. So this should trigger us to think of the product rule. Remember that? So product rule, that's what we're going to apply here. So we're going to write down the first. Remember, this is like our u and our v. So we have u times v prime, so x times derivative of the second, plus, so this is the second term here, plus derivative of the first, and then times just the second by itself. Okay, so that's the second term, and then we have something else going on here. This is, we're taking the derivative with respect to x of a y squared. So that means that we get we're going to derive with respect to y first, so that would be 2y, and then we have our dy dx left there. Okay, and the same goes for this one. I'm kind of integrating step 2 along with step 1, so this is step 2 at this point. Alright, so then this one if we integrate with respect to y first, we just get a 4. Okay? And then we have our dy dx left there. It's kind of just stuck. Okay? So now let's, I'll copy this last line down on the next slide. Alright, so we have a 2x, that was our first term, and then we have plus an x times ddx of y, okay, and then plus ddx of x times a y, okay, that's our second term, or our second and third terms now, and then we had that plus 2y dy dx, that was the derivative of y squared with respect to x, okay, and finally we had 4 dy dx, and that again was the derivative of 4y with respect to x. Okay, so moving along, let's solve for these things, and then we'll simplify and go on to the third step. So 2x plus, now let's see what we have. So x times, and the derivative of y with respect to x is going to be the derivative of y with respect to y first, so that would just be a 1, and then we have to add in that dy dx, because we don't know the exact relationship between those two variables yet. And then here we have ddx of x, so that'll just come out as a 1. Then we have that multiplied times a y. Then we have 2y dy dx is equal to 4 dy dx. Okay, so now we can kind of just pull out, so this is our entire equation, right? So now we're at step 3, and we're going to solve for our dy dx, okay? So let's gather all of those terms up, and we'll kind of just, what we can do is just squish them to the right side, okay? So what we're going to do is I'll just rewrite this equation here, so we'll see where we're going. So x times dy dx plus y plus 2y dy dx, and then we have that 4 sitting over there, 4 dy dx. So we're going to move all of these terms, these ones here, we're going to move them to the right side. So we'll just subtract them over, okay? So we're going to subtract an x times dy dx, and we're going to subtract that 2y dy dx to the right side. So then if we do that, we get minus x dy dx on the right side, and minus another 2y times dy dx. Okay, so on the left side, all we're going to be left with is a 2x plus a y, right? Because we subtracted the other terms over to the other side. And then we get 4 dy dx, which was already on the right side, and then this new minus x dy dx, and a minus 2y, that's a 2y dy dx. Okay, so we're almost there. I'll write this last line here on the top of the next slide so we can continue and wrap this up. Okay, so we have a 2x plus y is equal to 4 dy dx, okay, and then minus an x times dy dx, and then minus a 2y dy dx. So at this point, we can just factor out this dx from each of these terms, all right? So let's see what we get. So 2x plus y is equal to 4 minus x minus 2y. And then we have that dy dx being factored out. Okay, so now to get dy dx by itself, all we have to do is divide by 4 minus x minus 2y on both sides. So if we do that, 4 minus x minus 2y. So on the right side, these ones cancel, top and bottom. So finally, we get that our dy dx is equal to simply 2x plus y, and this is over 4 minus x minus 2y. Okay? All right, and we've reached our first derivative. And again, this was through using implicit differentiation. I hope that helps, and good luck on your homework.